Hello, welcome to Picture Me Coding. My name is Erik Aker. My co-host, Mike Mull, is with me today. Hello, Mike.
Hey there.
Mike, I have a question for you. Here's my question. Think about it. If you could meet anyone alive today, who would you meet? I was driving in the car with my son, who's 9, and he asks me this question the other day, and I have absolutely my mind completely draws a blank. And I'm thinking, there's got to be people I would say I would want to meet them and hang out with them. My problem is that for people who are famous or interesting, they're producing interesting content or whatever, I usually think we're not going to have a lot in common. They're not going to want to hang out with me, and I'm not going to want to hang out with them. So that doesn't sound that fun. So
Is the context that you meet them and you like have dinner with them and chat with them, or is it like
yeah,
you meet them in a dark alley and you have to fight your way past them?
no, I think it's more the former. There is a slight chance you could be friends. You have enough of a hangout
Hmm.
to share humor and stuff. Anyway, here's why this question comes up. I completely drew a blank when he asked me this a couple weeks ago. And then this week you said, hey, there's a new Aesop Rock album out. And I immediately, light bulb, went, oh, that's the person. That's the person who I would say in response to, I would hang out with that person. That person is hilarious.
It's very funny.
So there's a new Aesop Rock album, and I knew it was coming. I forgot about it, though. You reminded me, and I was really happy you reminded me. And I find him to be, the new album's called Integrated Tech Solutions. He's like a Kurt Vonnegut or George Saunders of hip hop. The guy is hilarious, and his observations are satirical and witty and insightful always.
Yeah, and the music is catchy as hell. So
Music is good too. So I have loved all of the last 5 albums he's come out with. The last one was Spirit World Field Guide, and I really love this. There's always these lines that get stuck in my head. One of them that got stuck in my head from that album was, we've never seen a man so vehemently drawn to the beast. I heard he plays a pipe organ and changes form when he feeds. And then he says, I've never played a pipe organ. The rest my lawyer concedes. Gets stuck in my head. There's a song from Malibu Ken where there's a webcam with a bald eagle on it, and it's eating a neighborhood cat, and he's imagining like you're just trying to escape your 9-to-5 life, so you're tuning into this inspiring webcam and you see your cat on this webcam getting consumed by an eagle. There's a song from Impossible Kid that always gets stuck in my head about his little brother playing Little League, and somebody spots a gopher in the outfield. And so the coach just unceremoniously grabs a bat and smashes it and then throws it over the fence. And he says, in a scene that would try every child as adults. I just find that to be absolutely brilliant. In the same song, his brother wants to go to a Ministry concert, and his mom shuts him down, his older brother. And his brother says, this is something I am willing to die for. It's so funny, but there's so much I sympathize with. Anyway, I think the best moment for me so far, I really like the new album. I like everything on it. Everything on it. It's got a lot of stuff that's inevitably going to get stuck in my head. It's got a lot of hilarious stuff. But early on in the album, there's a song called Mindful Solutionism. And there's this theme throughout about technology. And he's got these lines. I'm going to read to you some of them. He says, he's talking about technology. You could split an atom willy-nilly. If it's energy that can be used for killing, then it will be. It's not about a better knife. It's chemistry and genocide. And he kind of goes on, his landmines, Agent Orange, leaded gas cigarettes. He says, cameras in your favorite corners, plastic in the wilderness. This is something I sympathize with. I complain a lot about plastic in the ocean because we go to the beach a lot. He says, and this is what I had for you, we cannot be trusted with the stuff that we come up with. That's an interesting take for us technologists. We can't be trusted with the stuff we come up with. Anyway, I love Aesop Rock. What do you think?
lots of great lines in there. When I was listening to this latest album, I kept thinking, oh, I should send that lyric to Erik, and then I remind myself, oh, you're listening to the album too, so you've probably already heard it 6 times. But
yeah, I've been listening to it a lot, and I will probably listen to it for months. and it's going to go into that pantheon of stuff that just gets stuck in my head. If my son asks me again, who would you meet? I'm going to say, I would meet Aesop Rock. Age, sort of similar. Guy is hilarious. I could imagine actually hanging out with this person. Maybe that's a
Yeah, it's a good
dumb
choice.
fan thing to say.
I will think about it and hope to come up with something by the end of this episode.
What have you been listening to?
So I am a Bach nerd, as in Johann Sebastian Bach, as I think you know. Um, part of it is my upbringing. My mom was a church organist for a long time and a pianist. Um, and it's been a pretty good year for Bach nerds.
2023 has been a good year for Bach nerds.
Surprisingly, yeah. One of my favorite pianists, Vikingur Olafsson, came out with his own version of the Goldberg variations this year. And
Oh, you've sent his work to me before.
yeah, I really like him. You know, he he tends to put out albums that are not uh, larger pieces. Like he doesn't do concertos and sonatas so often. But this is just, this latest one is just the Goldberg variations. Um, However, what I wanted to talk about this week is, despite being a Bach nerd, I'm apparently not a big enough Bach nerd because I discovered recently that there's this guy named Ton Koopman who has recorded all of the Bach cantatas.
Can you spell that last name at least?
Koopman.
Oh, okay. And a cantata is like I don't know. I want to make a dumb joke about eating in a Mexican restaurant.
Yeah, that would have been a good joke. Yeah, it's a choral work usually for sacred purposes. Most of Bach's were written for the church, although not all of them. There are secular ones as well.
So gospel songs.
Yes, 17th century gospel songs.
Okay, so that's what a cantata is.
And there's kind of this idea that Bach wrote just tons and tons of stuff, and if you really want to find the great tunes, you have to listen to all of the cantatas because that's really where they're at. Not
You got to
entirely.
dig in those record bins.
Yeah, the ancient record bins. Not entirely true, but So I've listened to a lot of the cantatas over the years. There's a guy named John Elliott Gardner who's recorded most of them, and who is specializes in what they call period instruments. And so anyway, I did not know that this person had recorded all of them as well with his own group. He's a performer as well as a conductor. It's a good opportunity for a Bach nerd because now there's a whole set that I can listen to in sort of chronological order, and I can compare and contrast them with other people's performances of them. And so anyway, that's what I've been nerding out on lately.
That is so far beyond my any attempts I've ever had to appreciate any classical music. I'm going to listen to a piece and compare the performance of the piece to someone else's performance. I guess I have done that with jazz. Would not be if I wanted to be a Bach nerd neophyte. I want to come up to the Bach nerd temple on my knees and start to study. What do I start with?
That's a pretty good question. I think the most popular thing these days are the cello suites. There's a lot of Bach's greatest hits type albums, which
Bach classic rock type stuff.
exactly. Some people kind of look down on such things, but I do not. That's where I started out when I was a kid. So just look through the sort of compilation albums. I think is probably a good place to start, and then there's the cello suites and things like the Brandenburg Concerti, which are very popular. But it's such a large catalog of music, um, so many variations of it. You know, I don't know how many times people have recorded the Goldberg variations, but I can think of five that I listen to on a regular basis. So it's
Really different. You listen to different versions of the same.
yeah, and some people find one that they like particularly more than another, or some people are obsessed about Glenn Gould's recordings and so forth.
Oh,
But I just like listening to the different way people handle them. Uh,
hmm.
it's not necessarily that I like one better than the other. I just like hearing the way different people interpret them.
Hmm. I kind of wonder though. The interpretation's probably not as far flung as when I listen to Cat Power doing Bob Dylan.
No, although you do get people who will, do Bach in what sounds more like a 19th century romantic style. Um, you'll even find, although I don't particularly like them myself, you'll even find like electronic or versions of Bach that have beats behind them and stuff like that.
Oh,
So
that doesn't sound like if I'm going to the Bhakti Nerd Temple, I could be a neophyte and enjoy that.
yeah, I try not to be snobbish about it, but it's not something that I personally enjoy.
It sounds hard not to be snobbish about. It takes effort. This week, I wanted to ask you a question about this problem that shows up regularly for me, for us, for people I work with. We deploy a lot of stuff on Kubernetes clusters. And people come to me with these questions sometimes. And the question will be something like, here's one that showed up this morning, for example. I have a service and it makes an HTTP request to some other thing outside of our cluster. And it always works, except today, randomly. It didn't work. There was a problem, and it was trying to do a TLS exchange. So this is an HTTPS request. It's a secure request. It's encrypted. You have to do TLS, exchanging your keys to be able to agree on the encryption you're going to use between the client and the server. And it failed. And it doesn't seem like it just like the network just stopped. It just failed. And immediately after, everything else worked fine. What happened? And sometimes, not always, but sometimes when people tell me this, I go and I start looking at stats about their app, and I start to see like their app's working fine. There's no smoking gun in there, but apps nearby their app on the same virtual machine suddenly got real excited and started doing a whole lot of work. They started maybe taking up a whole bunch of CPU, and there wasn't that much for this other pod in the Kubernetes land. And it's possible that restricted its ability to do the TLS exchange. And I don't know for sure. So we get into this conversation of, look, there's a bunch of pods all running on nodes. What are they asking for? And is that enough? And it becomes this large abstract question. How much CPU does my application need to run? How much should it need? Do I need to know about all the other things that are running next to my application? That kind of sucks. You ever see this problem?
Yeah, yeah, um, it's quite common, and as you know, and it's also quite kind of interesting that if you start to Google about it, you'll see roughly equal numbers of articles that say you should never use CPU limits and other articles that say why you should always apply CPU limits.
Yeah.
And both of them make pretty good arguments.
I want to talk about that first. So, if you go on Reddit and you talk to people about Kubernetes, this question comes up all the time. So, with the Kubernetes deployment, you schedule pods. Kubernetes can schedule pods. A pod is one or more containers. For your pod, you can set resource requests and limits. So, there's memory and CPU. And when you talk about requesting memory and requesting CPU and limiting memory and limiting CPU, it's already abstruse about what we're even doing. When I request CPU, what am I doing? When I limit CPU, what am I doing? And there is a conventional wisdom that propagates around the community. You see this on Reddit, where people will say, I've got these CPU limits, and 80% of the response will be never set CPU limits. Never. And there are people like Tim Hawken, who is an engineer at Google, who was one of the first engineers working on Kubernetes. And he's quoted all the time in this conversation. He's got a tweet from 4 or 5 years ago where he says, "I always advise set your memory limit equal to the request, never set a CPU limit." But then he has a footnote at the bottom of this post where he says, "Well, this is for locally adjusted values of quote, always and never."
Right.
And I kind of have a rant about this. Every time I see people commenting and saying never set CPU limits. Now, obviously, I don't have the credentials to argue with Tim Hawken, but when people say to me never set CPU limits across the board, I always think about this thing that I ran that just went nuts and sucked up all the CPU. And the thing is actually a log aggregation tool. So we use Grafana to look at what's happening on our clusters. We collect CPU and memory using Prometheus. We collect logs using a tool that Grafana publishes. The name of that tool is called Promtail. And there is a problem, or there was a problem with Promtail, which has been fixed. It's written in Go, and it had a Go routine leak. And if I didn't have a CPU limit on that, now that was providing a useful service for us. But every so often, after a week or two of running, it would shoot up to whatever the CPU limit is and just stay there. If I gave it 10 CPUs, it would take 10 CPUs. And so I had to put limits on that thing so that it didn't completely overwhelm the node and not allow anything else to even operate on the machine. So when somebody says to me, never set CPU limits, I feel like this is too hard and fast of a rule to be applicable in the real world.
Yeah, I think that's probably true. Um, I think what we've found empirically is that turning off CPU limits for our deployments gives us better results. That the problem that you were describing where um, HTTPS requests are timing out often turns out to be a case of you sort of arbitrarily limited the CPU, and so that process gets throttled right in the middle. And so it's not so much that the network is slow, it's just that that thing is being stopped kind of in the middle of its work. And taking those limits out generally eliminates that problem. So, in the case where you've got a deployment that is not particularly CPU bound, then taking out the limits probably is fine and probably is going to give you better results in most cases. I think the reason why this is such a difficult thing to reason about is because ultimately you have to get down to the level of the kernel scheduler.
Mm-hmm.
And
Mm-hmm. Yeah, I want to talk about that because I know that you've looked in detail at the Linux kernel scheduler. So that's why I wanted to raise this for you. And this is our 15th episode. My hope is that we're 15 years old in podcasting years at this point, that I'm mature enough. I've developed enough of a frontal lobe to be able to handle this reasonably. That's my hope.
it's not like dog years where every 7 episodes is 1 year or something like that.
Oh, maybe it is. I don't really know how you do this. I'm still new to this math.
Yeah, I guess we'll have to figure that out.
So, wait, so should we talk about what a CPU request means and what a limit means first? Or do you want to go to the bottom and talk about what a Linux machine does when it's scheduling CPU?
Well, let's see if we can find common ground on requests and limits. In part because there, one clarification I want to make is that when we're talking about Kubernetes, there's really at least two schedulers that we may talk about. One is the
Okay, that's fair. So the control plane, right, which has a service, which is the scheduler, which figures out which node you're running on.
right. So, when we're talking about limits and requests, initially we're talking mostly about the Kubernetes scheduler, which, as you say, is a control plane thing. And this is a statement made somewhat from ignorance, but my belief is that once that thing applies the limits and requests and various other taints and tolerations and constraints that might be applied, and maps the pod onto a particular node, I think its work is done. So
Yeah.
I don't think it's doing anything active to monitor and manage the pods that are running once they've been scheduled.
Yeah. So, right. Scheduler puts it on the node. That's right.
Right. So I think that's where the request comes into play, because essentially when you're adding a request level to a deployment, you're saying, I'm going to need at least this much memory and this much CPU. So unless you can find a node that has that available, don't even bother starting me.
Hmm.
That's how I think of it in any case.
Yeah, that makes sense. If I request 10 CPUs and I don't have a node in my cluster with 10 CPUs, then it's never going to get scheduled.
So then the limit is, if I exceed this amount of CPU or this amount of memory, then don't allow me to do that. Take whatever action keeps me from using more of that than I have set the limit to be.
I like that you use the word action because when we put memory and CPU together, in my mind, they're so separate. Because memory, if you exceed memory, your pod gets shut down and restarted. You get out of
Right.
memory killed. Some people say killed.
Yeah, I like to say kill just because of the sound of it. But
But you don't get CPU killed. You get CPU is a quote unquote compressible resource, and that's where things start to get really magical.
yeah, I mean, you can theoretically get starved, but um, hopefully, if the scheduler is working correctly, if the kernel scheduler is working correctly, you won't.
Mm.
Um, so anyway, so the limits and requests at that level apply to the Kubernetes scheduler. That may be a bit of an oversimplification. Um, so I also believe there's a detail in here that which we probably need to talk about a little, which is C groups.
Mm.
Um, so my understanding is that the limits essentially get, so the mapping between the limits that you set in your Kubernetes deployment and the limits that are in the kernel scheduler are essentially described through what Linux calls C groups. Um, so all the processes in your pod are essentially assigned to a C group, as I understand it. So anyway, once the Kubernetes scheduler has said, yes, you can run on this node, then there has to be the other level of scheduler is the kernel scheduler, and that's going to take a particular thread that's in your pod and put it onto a CPU and give it time to run.
Time to run.
So the sort of standard Linux scheduler at this point in history, this being the end of 2023, is what they call the CFS scheduler.
Hmm.
Um,
It's completely fair. That's
it's
why it's CFS.
supposed to be completely fair.
Completely fair.
Um, and so the idea here is that you have, um, it's kind of a nice idea. So there's this idea that you have like a virtual CPU, and that in an ideal scenario, all the processes um, would get some percentage of that virtual CPU. And so
Hmm.
what the completely fair scheduler is trying to do is give them slices of time on a real CPU such that they're getting roughly the same runtime they would have on this idealized virtualized CPU.
Hmm.
Um, so what happens when you set limits is that the scheduler in the Linux the Linux level scheduler, when you set limits, may end up throttling, which means taking off the CPU some process that in your pod that's running before it's completed its work.
Right. And it doesn't mean that you get less CPU. What it means is you don't run for those CPU shares, right? Until you get another one.
Right. And so you're sort of adding a latency that may turn out to be artificial, because your actual node that's running these processes may have plenty of CPU
Hmm.
to handle all the processes that are currently part of that pod, but you've placed this limit on it, and so the scheduler is sort of artificially stopping it.
So maybe we could make that a little more real. So let's imagine I've got some API servers, HTTP servers, pretty common for us, HTTP server, pretty common for us to deploy. It's receiving requests. Maybe it's got a lot of volume at certain times of the day. Maybe most of its requests, it's responding in 200 milliseconds or less. If I don't put a CPU limit on it, in general, it'll probably be able to return. If I put a CPU limit on it, then I know that for each CPU share, it's only going to get that portion of the share that I've specified up to the limit. Is that an okay description? I'm trying to simplify it, but maybe I said something wrong there.
I think that's right.
So in Kubernetes land, we often do this with millicores, so a thousandth of a CPU. And typically the CFS chunks are 100 milliseconds. It can be changed. You can change that, but I don't think people do really from what I've read. So let's say 100 milliseconds is a chunk, a CPU share. And I define my app as needing 500 millicores, right, out of 1,000 total. So that's half a CPU. So if I limit it at 500, what I'm saying is you should only let my service, my container run for 50 milliseconds, and then you should make it wait for another CPU share, which could be another 50 milliseconds. So maybe 50 milliseconds, wait 50, 50 milliseconds, wait 50. If it takes 200 to complete, then now it's going to take, you know, to get 200 is going to take twice as long now, total time.
Yeah, that's a good way to describe it. Um, so the there is, like, suppose you have two processes that are just CPU bound, so they're always runnable, and you only
Hmm.
have one CPU, then they're going to be sort of trading this time slice of however many milliseconds. The one detail about the CFS scheduler is that as the number of processes per core gets larger and larger, there has to be um, that time slice has to contract a little bit. So you can't give you can't give you can't give every process a full 50 milliseconds or 100 milliseconds or whatever the specified amount is after you get a certain amount of processes running. So
So again, to try to ground that for me, let's say we got one CPU and I've got 10 processes. Obviously, every process can't have a full CPU for every share. I have to break it up, right? That's what you're saying?
yeah, and let's say that you do have 10 processes and you've decided that your sort of time slice is 100 milliseconds. Um, and these things are CPU bound, so they're always in a runnable state. Then, um, at some point, if you get 15 processes or 20 processes, you can't give everything a 100 millisecond time slice, because then you're sort of exceeding the amount of CPU that you have available. So at
Hmm.
some point, you have to sort of contract that time slice. Although
Well,
there is kind of a
when you
limit
say,
to how small it can get as well, because
Mhm.
there's sort of a latency involved in swapping one process with another process. So there's not, you can't make it, you know arbitrarily small. There's some limit to the lower end of the time slice.
I thought that the lower end for at least for our Kubernetes pods is like 5 milliseconds or something. So no fewer than 5 millicores of CPU is what you could specify. But what I want to do, Mike, is I want to just shove a bunch of containers over there and say, you figure it out. Well,
Yeah, it's extremely hard to reason about, because you're generally not talking about processes that are CPU bound. You're talking about a combination of processes that are, some of which are CPU bound, some of which are IO bound. Um, you're talking, in our case, you're talking about asynchronous web applications sometimes, which have their own scheduler in their runtime. And so you can't even really see the processes running on the Linux scheduler. You just basically see the runtime on the Linux scheduler. So and in these days you've got machines that have um, you've got numerous cores, but the cores may not all operate the same. You may have some cores which are more powerful than others. You may have cores that need to be sort of warmed up. Um, they're so yeah, that the literature and research on schedulers is very interesting and mind-boggling, but I still haven't reached the point where I can reason about them. Uh,
I find it hard to reason about as an application developer, and I find it to be one of those topics where I'm like, how much should I know here? How much should I know? How far down the stack should my knowledge go to be able to reasonably figure out what I should do for my app? And when I've got developers coming to me, they're deploying stuff alongside things that other people are deploying. They don't even know what's there. They don't know what those other things are requesting for resources. Are these things in competition somehow? This is where it gets pretty hard, much harder to reason about. The number of variables involved is so vast. I'm curious, it, like computers didn't always work this way. Do you remember how it used to be years ago? I mean, before the completely fair scheduler existed, what did you have? How did you solve this problem in the past? And I'm asking because I'm wondering if it gives you a mental model for solving it now.
well, going back far enough, I started off in an environment where there was no preemptive multitasking. So scheduling was less of an issue. You started up your editor, you did some editing, and then you turned that off. Shut that down, and then you started your program to, do some calculation. When
Mm.
that complete,
You didn't ampersand background stuff all the time.
not in my original uh, computers. No, uh, I first things I started programming were Windows PCs running DOS, and there really wasn't a concept of preemptive multitasking.
Hmm.
Um, the I think like early '90s was probably when Windows started to have true preemptive multitasking.
Hmm.
Um, the first multitasking machines that I used were things where they kind of gave you equal time slices. So, there was some pre-specified time slice, and each program would sort of get a round robin uh, uh, chance at that time slice on a particular CPU. And then things started to get really complicated around the early 2000s when people started introducing multi-core processors. And
Mm.
um, at this point in time, you can just barely sort of reason about what's happening on a multi-core CPU, but there's so many edge cases and heuristics and handling of special hardware that it's very, very difficult to imagine what's going on.
I think there's another problem which when I look at our metrics, right? We're using Prometheus and it's telling us here's all the CPU shares that your container is used. Here's all the CPU shares in which it was throttled. Um, here's your utilization, what you requested and how you limited it. I can look at that stuff, but our sample intervals 15, 30 seconds. That's pretty wide, right? So every 30 seconds I'm going to take a sample. Does that really show me if there's a problem that persists beyond that interval? Sure, I'm going to see it. But when somebody comes to me and says TLS failed at this point in time, I'm looking at it like, well, this other process on that same node that you're on spiked its CPU usage and went to 100%, but it didn't take all the CPU on the node. There should be more left over. Is that what happened here? And I find myself pretty much in the dark. There is, go ahead.
No, I was just going to say I think you're right. The the granularity of the server metrics that we get are not particularly helpful at analyzing CPU level problems. And I think that's why this is such a hard problem for us and for people in general. Is just, you're really trying to figure out at a very high level what's going on at a CPU that you may not really have access to.
Mhm. So the argument not to add CPU limits, I do find it compelling for most of the things I deploy, but there's stuff I don't trust.
Right.
And I want limits on those things. So as like an across the board rule, no CPU limits, I can't do it. I gotta limit some things that I don't trust. So if you look at the Kubernetes docs, I'll quote from them. They say the CPU limit defines a hard ceiling on how much CPU time that the container can use. Okay, that makes sense to me. Hard limit on the amount of CPU time the container can use. Now they talk about the request. As we talked about, the request helps the scheduler figure out where the pod gets scheduled, which node it goes on to. The CPU request, the Kubernetes docs, right, typically defines a waiting. If several different containers, and they put C groups in parentheses, want to run on a contended system, workloads with larger CPU requests are allocated more CPU time than workloads with small requests. Well, I find this to be an extremely important detail because when people say, sometimes, not everybody, I'm not trying to say everybody has this argument, but I've seen the argument never set CPU limits, always set CPU requests. You are guaranteed to get your request. And I'm like, wait a minute. I can see how you might be guaranteed to get your request. Here's how. Let's say we run a lot of Python stuff at work. We run other things too, but we run a lot of Python. Pretty much everything we run in Python, we're not using multiprocessing. We're not using multi-threading. They're not going to use more than a single CPU. So I could take 5 Python services. I could ask for a full CPU for every single one of those. And those pods would be quote unquote guaranteed to get all the CPU they ever needed if I didn't limit them. But I'm wasting a significant amount of CPU for all the moments that those things are not in operation. So it'd be nicer to request less, get more resource utilization out of my node. If I look at my node utilization, it's like 5%, you know? If I request 200 millicores of CPU for all those things, there's 5 of them. Altogether, they're requesting about 1 CPU. You may have other stuff scheduled on there too. Now, if something spikes up to 1, we may have a contended system. And then we get into this, my favorite phrase. The requests define a waiting. So now if I have a pod that's requested 400 and a pod that's requested 2, well, the 400 gets weighted twice as much as the 200. That's where things get really weird. Can you make any sense of this?
So what I think is happening here is that the request essentially, I mean, this happens through the C groups, but you can think of it as getting mapped to like a nice value.
Mm.
So, if your request is twice, if request, if the request of pod A is twice the request of pod B, then you're essentially uh, giving the pod A twice the weight, twice the priority of pod B. And I think this is another problem that we see, and that we haven't really figured out um, a way to get around. I mean, I think we do okay because we're end up deploying these things to nodes that have lots of cores, and pretty much everything gets the CPU that it needs. But I think the issue that this brings up is that when you are, you may look at your service and say, I seldom use more than 500 millicores, so I'm going to set that as my request. And uh, you don't really take into account what other services are doing, and sometimes people will see that their thing is being throttled, or their thing is not running as efficiently as they want, and so they just sort of uh, blindly increase the CPU request to make it run better. And
Exactly. They add like padding around their thing. I'll
yeah,
request more CPU, and I'll get a little more breathing room around me.
right. And it doesn't give you using the tools that we currently have access to. It doesn't tell you how that's affecting the other things that are running on that
Yeah.
node, and
Yeah, you're right.
that's the problem that we haven't really, or that I at least have not really solved for myself yet, is figuring out how my request affects other people's processes.
And the reason I want to use Kubernetes, or one reason, it makes it super easy for me to deploy. That's one reason. But one of the primary reasons I want to use it is resource utilization. In the days before Kubernetes, I would spin up an EC2 instance on AWS, and I would put my code on there or even put a container on there and run it. And it would be like one server, virtual machine, per service or a couple services. And that was super inefficient. Kubernetes has the promise of we're going to pack your bins. Like we're going to take your nodes and we're going to shove stuff on there, and you're going to get great resource utilization. Well, not if I have to request max CPU for every single thing I might run. Then I'm right back to like I might as well have one virtual machine for thing. Maybe I'm overstating the problem. My problem is very hard to reason about. And when you start talking about my request is a weighting, a prioritization of how much CPU I get, very hard to reason about, because now I need to think about my request with respect to everybody else's request. That's I just can't, I don't want to do that.
Yeah, I think most people get away with it as we do because we're, like I say, we're deploying these things to nodes that really have probably surplus CPU, surplus cores. And so we rarely see things throttled on our deployments. But, I've read of these examples of things running at scale where, you've got enough processes that it's eating up 64 cores on something, and then you introduce something in there that doesn't have a CPU limit that wants to use 10 cores, and um, in those scenarios at larger scale, you can really wreak havoc if you are
Mm.
careless about requests and limits.
Yeah, those systems with contention. Yeah, that's right. I guess that there's this bind. On the one hand, if I request a bunch of CPU for all my things, I'm not going to get great utilization unless they all run at 100% CPU 24 hours a day, right? That's like, that'd be the ideal. They all run. I know exactly how much they need. I can request that. And then we put them on the machine and 100% CPU, great. If I don't have that scenario, my resource utilization to make them run in a safe way, I'll request maybe not everything, but a little more than they're mostly going to need. And then my overall utilization goes down. And the hardest part is I can't reason about, I don't want to have in my brain, I've got 100 pods on the node. What are they all doing?
Yeah, and it gets more complicated too when you have this mixture of CPU bound and IO bound processes. There's been a talk recently about what's likely to be the successor to the CFS scheduler in Linux. Um, I've forgotten the acronym or the abbreviation. It's something like EEVDF or something like that.
Oh, that sounds memorable.
Uh, but the idea there is that that you still want to keep things fair in the sense of giving processes adequate CPU time, but the idea is that some processes that are mostly IO bound and don't need big time slices of CPU are better off if they don't have as much latency. So if you if you have something that needs, like maybe an editor, let's say, it doesn't need a lot of
Hmm.
CPU time, but it's also going to be affected if it has to be swapped back and forth with some other process. And so this new scheduler basically tries to identify these things where um, the latency is a bigger issue than being throttled on the CPU, and try to give those more, adequate time to finish their work. Um, so it's yeah, just again, it's very difficult to reason about, and I think it's one reason why there's been so much work and and research on schedulers in general.
I don't have any complaints about CFS. I think it's a great technology. I'm glad it exists. And I don't want to be someone who's just complaining about all of the tools that I have at my disposal. I do feel like I need to reason about things that are very, very hard for me to reason about. It's a little gratifying to hear you say, yes, it is hard to reason about. It's not just you.
Well, I think you're right. That um, what you really want is something where you put deployments on this platform and it figures it out for you. And my only my only concern about that is I think what that leads to is probably serverless.
Serverless. I had a feeling you were going to say that.
Yeah,
Yeah. You might just go, stop running Kubernetes. Just do everything serverless.
but yeah, it's for me at least kind of an interesting problem to think about, even though I confess I'm still somewhat mystified by it.
Yeah. I guess if you go serverless and somebody is still solving that problem, it's just not me anymore. How'd you get into looking at schedulers in the first place?
It was a really sort of this Kubernetes problem. We talked about this, about how should we add limits, should we not add limits, and um, I started asking myself the question, what does that really mean? What does it? So, for instance, say you add a CPU limit. If you're adding a memory limit, that makes sort of intuitive sense. You're saying I don't want this process to use more than 1 GB, and if it does reach a point where it's over that threshold, then do something about it, and which may be killing it and restarting it. But it's much more difficult for me to imagine what that means for a CPU limit. And so, my journey into trying to figure out schedulers, which is still ongoing and probably nascent by most people's standards, is I'm just trying to figure out what it means when I say that I don't want this process to use more than 500 millicores. What is actually happening, in the kernel? What's happening on the CPU that's really making that limit effective? And it's still a hard thing to answer, especially in the context of other processes running and you know uh, trying to figure out how the async runtime is scheduling things inside itself. So
Hmm.
it's a very difficult thing to answer still, but it's a sort of fascinating problem.
Fascinating problem. CPU scheduling. These are the hot topics we get into here on Picture Me Coding. Well, thanks, Mike. I think you have made me feel a little more gratified that my frustrations are not totally misguided. I appreciate these projects. I appreciate what they do for me, as I said, but I find this stuff hard to reason about. And sometimes I'm kind of shaking my fist like, I don't know.
Mm.
All right. Thanks so much for talking to me today. This has been another episode of Picture Me Coding. We will see you again next week. We'll see you later, Mike.
I still haven't figured out who I want to meet.
Yeah, that was my question for you at the beginning. Maybe you got to save it till next week.
Yeah.
It took me until you mentioned Aesop's Rock album. This was probably took me about 2 weeks to remember who who would be a good candidate. It's not an easy question.
I think, does it have to be a living person?
That was the rule that my son put on it. It has to be someone living.
Okay.
If it's someone who's passed away, then it's hard. It's hard. Maybe it's not as hard. It's still hard because I don't know if people who died want to hang out with me.
Yeah, I sort of start with the assumption that all people living or dead probably wouldn't want to hang out with me. So
Well, at least in the case of the dead person, they're probably super bored. So they would
yeah,
hang out with virtually anybody. They're just hanging out there being dead, not doing anything.
yeah, that's a pretty good point. I could probably you know find some ghosts to hang out with who would be.
Yeah, talk CPU scheduling
Yeah,
with Galileo,
yeah,
Bertrand Russell.
that'd be a good hang.
All right, come up with an answer. It has to be someone living. I'll follow up next week on that one.
Sounds good.
All right, talk to you later, Mike.
See you next time.
Bye bye.